It's obviously a great shame that we can't be in the Lake District this year. We were really looking forward to returning there for the first time in 10 years, but it is very exciting instead to have so many people joining us from outside the UK. And perhaps we just need to remember that although we like to think of our walks as having been like this in beautiful sunshine with wonderful views, there are of course also the years when our walks look more like this and we lose people down the wrong side of the mountain. So you never know, perhaps we've had a narrow escape. But let's get back to the software. So what I did last year was to give you a general introduction to our version 3 software, which is much more modern, flexible and user-friendly than version 2. It does still lack some version 2 features, so if you're wanting to do relaxation analysis or calculator structure, you're probably still better off sticking with version 2 for the time being. But over the next 6 to 12 months, we shall hope to have ported most of our version 2 features to version 3. But for smaller projects, for titrations, assignments, version 3 is really nice. If you want to see that talk from last year, then you can have a look at that on our YouTube channel. What I'm going to do today is take a rather more focused look at one particular area of the software, and that's the way in which version 3 interacts with other programs and how you can be part of that. In particular, I'm going to take a look at macro writing. Why would you want to write a macro and how can you do so easily? Then using version 3 as a development platform, what is our environment and what are the advantages of developing your NMR data analysis tool in that environment? And then finally, the NMR Exchange Format. What is it and how do we envisage it enabling smooth and accurate exchange of data between analysis and other NMR programs and databases? So let's start with macro writing. Why would you want to write a macro? Well, over the past year, as I've been speaking to users at workshops or interacting with people by email, again and again, things have come up where people have said, oh, can I do this? And I've had to say, well, no, you can't, but actually we could quite easily solve that by writing a macro. So we had someone ask if he could easily set all the contour levels across his titration series to the same level. So we just wrote him this short little macro and that did the job. In the meantime, actually you can do it relatively easily using the graphical user interface, the GUI, but back in November that wasn't yet the case. This figure in itself, I actually created using a macro. I was looking at a series of spectra and I thought, oh, it would be nice if I could just colour them all in easy colours in one go. And so I just wrote myself this macro and I can reuse that easily each time I'm looking at a series of spectra. When Elisa first joined the project back in October, she first said, oh, where do I switch all my negative contours on and off? And so one of the first things she did was write this macro, which turns all the negative contours off and then an equivalent one to turn them on again. And you can then also, any macro that you write, you can in fact also associate with a 2-key keyboard shortcut. So now she and I both have these shortcuts to turn all the negative contours on and off. Then in conversation, email conversation with someone who was doing solid state NMR, we were talking about a number of different things and he was trying to edit his peaks in one way or another, and actually as part of that I realised it'd be very easy just to write a macro which would take any peak that you had selected or several peaks that you'd selected and mark them as a sideband or artifact peak, and you could just have a little macro that automatically sets the merit to 0, writes a comment as to what the issue is, let's say it's a sideband peak, and then marks them in a different colour so that you know, okay, beware of those peaks. Then in one of our workshops at ETH, someone showed me a figure that looked something like this and sort of said, oh, could I be able to do this kind of figure with analysis? And what he'd done was have different peaks coloured in different colours according to particular values. And I can't remember exactly where he had those values from, if they were in the B factor column of a PDB file or something like that. But either way, that is the sort of thing which probably we would be unlikely to ever implement as a feature, and yet actually you could do that quite easily using a macro. So macros can be useful both as a means to just help you in your everyday usage of the program, create little shortcuts for things, but also for bespoke features, that things that you might be interested in doing that probably no one else out there might necessarily be interested in doing. Now, of course, it's very easy for me to stand here and say, oh, you just write a little bit of code, and there you go, you got your macro. Of course, you're thinking, how would I know which bit of code to write? Well, we've tried to make that process as easy as possible. Some of you may remember the version 2 data model, which is very complicated. It's detailed and thorough, but getting your head around it is quite difficult. So instead, what we've done is, that data model is still there, but it's rather hidden, and instead we've got a much more simplified data structure. So it looks something like this. Just a few main types of data, and then a few bits that are nested. So obviously a peak has to belong to a peak list, which in turn has to be associated with a particular spectrum. On the whole, this is fairly simple. And the nice thing about it is you don't even have to remember it, because it's also reflected in your sidebar when you open analysis and you have put your data in. It is shown in the same way, using the same sort of nesting. Now, each of these different types of data, we refer to them as classes, and then each data item within that we would refer to as an object. So all these different types of data, these classes, have associated with them so-called methods and properties. Now, methods you can think of simply as subroutines or functions. Properties you can essentially think of as variables. And these will enable you to access and manipulate all your objects, all your bits of data in your project. So an example of a method might be, for a spectrum, would be rename. That would allow you to rename your spectrum. For a peak, one of the methods is assign dimension, which obviously lets you assign one dimension of that peak. Examples of properties include things such as the path where the spectrum data is stored, or spectral width and other spectral properties. For a peak, the properties might include things such as position, height, volume, the comment. Now, another way of accessing your data is through so-called project IDs, or PIDs for short. So every object, every item of data in your project has a unique project ID, and we've tried to keep those simple. They're actually these names that they have here, again in the sidebar of your project. So a spectrum, for instance, here would be SP:HNCA, and then the peak list would be PL:HNCA.2, for instance. So we've always got a two-letter code at the beginning, which specifies the type of data, SP for spectrum, PL for peak list, PK for peak, etc. And then comes the name, and you can see that the nesting is also reflected in the project ID. So the peak doesn't just have a number 219, is HNCA.2.219 to reflect the fact that it's in peak list 2 of spectrum HNCA. Okay, so now we have got a means to grab hold of our data items. We've got all these properties and methods. How do you actually know what all those properties and methods are? How can you find out what they are and start using them? Well, there are a number of different ways in which you can do that. Perhaps the easiest way is to use the way in which commands that you execute on the GUI are echoed on the console. So if I press the spacebar twice, I'll bring up this Python console, and you can see the top part is where commands are echoed. So as I'm executing things here in the graphical user interface, you can see that those commands are echoed in this top section of the console, and I can then just copy and paste those, take those and use them in my macro. Another way, believe it or not, to get hold of methods and properties is using the documentation. So under help, we can go to show documentation, and then this core package part includes information about all the different data types and all the different classes. So if, for instance, we go to peak, then you can see here There's a list of all the different methods here, add assignment for instance, and then properties are labelled as being properties, and you can see all of those. And for the methods you can also have a look at the source code if you're interested in that. Another way to find out about properties and methods is to do that directly on the Python console using the lower part of the console where you type things in. This is something that I know both Gerten and I do on a regular basis. And so here I'm just taking this variable sp and setting it to a particular spectrum. So you can see I'm doing this get by PID, so I'm just typing in this project ID, which I can see here on the left, just checking that I haven't done a typo. And then if I type sp.tab, I get all these properties and methods. I'll escape and get back again. And perhaps if I just type sp tab, then I can just see all those starting with sp and find, okay, here we go, spectral widths, hertz, that's the one that I was looking for, and then those values echo to me. And then finally, another way to find out about methods and properties is to use our new macro editor, used from version 3.02 onwards. So what we've done, this macro editor is nearly heading towards being a bit like an IDE, a so-called integrated development environment, which is essentially a sort of bells and whistles text editor that programmers use. And so you can see here I am just setting this variable CMT to be, this is my favourite peak, and then as I type something here I get these different options, peak, and as I type peak dot it gives me again those options that I can choose from. It even finds the variable I've set further above, or equally if I'm wanting to look not for a property but for a method, again I can autofill a peak and then assign dimension, again it'll just autofill that. It will also autofill things like brackets and quotes and that kind of thing. So this hopefully will just make life easier, jog your memory, or help you if you're looking for a particular task and you're thinking surely there must be something along those lines and you're looking for it. You can do that directly here while you're editing your macro. Now this is the point where I would have said, and we've got a new wonderful macro writing tutorial which you can access from within the program. Unfortunately, it turns out that when you're organising an online conference using software that no one has used before, and you're also having to homeschool your children, and your boss has been out of action for the last 3 weeks, that life is a little stressful and you don't actually manage to get right down to the bottom of your to-do list. So still languishing there is finish off macro writing tutorial. So at the moment we have about a third to a half of this. Hopefully by the end of the summer it will be done. A new macro writing tutorial which will take you through all of this macro writing, some of the things I've just been talking about, take you through step by step building up writing different types of macros. It assumes very little in the way of Python knowledge. It helps if you know what the indents are there for and some of the basic syntax, but other than that really the entry level is hopefully very low. Now you can make your macros as simple or as complicated as you want. You can add pop-ups, you can add graphs, all sorts of other graphical elements if you like. But at that point we're starting to get to the point where actually you're moving from not being a macro, but you're starting to use version 3 as a development platform, starting to develop nearly your own program. So this part of the talk really is aimed at people who are starting to write their own programs to analyse NMR data. So perhaps you're writing a new peak picking algorithm or a new way to automatically assign your spectra, or perhaps you've developed a new pulse sequence to get us some interesting dynamics information about your protein, but you need to take the raw data and fit it to some equations or do some other mathematical manipulations with it before you actually get the information you need. So as well as providing all the methods and properties that we've written, that I've just been talking about, we also provide a whole load of packages that have been written by other people with a whole load of methods in them that you can use and access. So this is the full list, I think from version 3.01 of packages that are included. We've now added 1 or 2 extra ones for 3.02. I won't go through them all, but just highlight a few. So obviously we're working here in Python 3.8, We use Qt to do all the graphics, to do the pop-ups. We do our graphing primarily with PyQt Graph, but we've also included Matplotlib, which is popular with many people. We've got NumPy and also SciPy, which include a whole load of mathematical routines. NMR Glue includes things specific to NMR. Pandas data frames is something that we're finding increasingly useful when dealing with large data sets. So Luca has been using that a lot for some of the screening work that he's been doing. HDF5 is a new way of specifying spectral data, and that's how we save spectral data within version 3. It's particularly useful when you go to higher dimensions and want to be able to retrieve the data very quickly. And finally, it's perhaps also worth highlighting this scikit-learn, which is an AI package. So we use that for the principal component analysis. But these are all things that you might well find useful as you want to write your own algorithms and programs to analyse your data. Obviously, if there are packages that are not included that you would like us to include, then we can do that. We don't want to be doing this all the time because adding new packages means we have to do a new build and people have to re-download the software from the website rather than just being able to update it with the update mechanism. But it very certainly is possible to add additional packages if that's what you need for your programming. So what are the advantages of using this version 3 environment to do your programming? Well, for a start, all of that is already there. You don't have to bother installing it. It's ready for you to use. We're also all set up on GitHub, so we can easily add you as a developer, and then you can easily integrate with all of our code. And then, of course, you've also got access to all of the stuff that we've already done. So if you're developing a new peak picker, for instance, it's obviously also quite useful to be able to visualise your peaks and look at your contours. Well, there's no point in you having to repeat all that work of programming something that will display contours and peaks because we've done all of that. So you can just piggyback on all of those fundamental basics that we've already done, and then you can concentrate on the exciting new stuff, which is sorting out the real peaks from the noise and the artifacts. So these are some of the advantages to you as a developer. There are also a number of advantages to your users. So we've got hundreds of users right across the globe, and obviously for them it's very convenient if they can install your software simply by clicking on our updates button. They will particularly be thankful if they don't have to download your software, then download the 4 packages that it depends on, discover that they need a new compiler in order to get that all to work properly, then find that there are probably about 5 libraries that they are missing and they need to install in addition, and then the next time they do it on a new computer with a different version of the operating system is all totally different yet again. Let's face it, we've all been there. So hopefully you'd be making life easier for your users, but it also means that in one go you've got access to a whole load of users who can very easily get a hold of your software and then start using it, and let's not forget, start citing it as well. We can also help you with publicity, so if you wanted, we could have everything ready to go with your plugin set up, and then the day that your paper is available online, we can pop it onto the update server and just send out an email on our mailing list, pop it on Twitter, whatever, and tell people, right, now you can access this new software tool. And finally, we can also help you with preparing some of the documentation. So obviously we've got our YouTube channel where we do video tutorials. We can easily incorporate one using your tool, and we can also host some other documentation on our website if you don't want to have to host your own website. Now I realise some of you are probably thinking, oh dear, this is a CCPN trying to take over the world, and of course in the age of Trump and Johnson and others, that's not an entirely unappealing thought. However, we are not here to control or dictate or take over. We are here to enable, to support and to highlight other people's research. We are funded by the MRC on a partnership grant, and their remit is specifically for us not to publish lots of exciting things ourselves, but to enable you to publish lots of exciting things.
So we hope you will see this as an offer to developers to be able to concentrate on the new and exciting stuff and not have to bother reinventing the wheel on the old boring things, and an offer to the NMR community to enable scientists to concentrate on the science and not have to faff around with their computers all the time.
Now, this is all very well as we look to the future and people developing new things. What about all the software that's already out there? Well, that's where the NMR Exchange Format, or NEF for short, comes in. So this is a project that started quite a number of years ago. You can see this paper is from 2015, but it started well before that. And you can see that there are really a very large number of different NMR software developers who have got involved with this in order to develop a new way of exchanging NMR, in particular NMR restraint data, between programs and databases. NEF is now finally starting to come to fruition. So we have a format specified. It is a star style format. So the files look very much like NMR star files or MMSIF files. They have these so-called save frames, so these sections that are bracketed by these save statements that each refer to a different section or a different set of data, and then these loop sections which are a means to save tabular data. NEF files have a number of different save frames specified. Only these top 3 are mandatory, so there's a little bit of metadata you need to provide, molecular system, so that's essentially your sequence, and then chemical shift list. And then it's up to you whether you want to include any of these other sections, so peak lists, various different types of restraint lists, a section that can link peaks to restraints, and then also different programs can provide program-specific save frames. So CCPN, for instance, we've got CCPN-specific save frames, so if you save an F file in analysis, you can save those and you can pretty much save the whole of a project. In fact, at some point we may even go over to saving all of our projects as NEF files. But so that's a way for us to be able to use NEF as a means to save things, but other programs can just easily ignore that if they want, and they won't fall over. The other thing that NEF specifies is atom naming. So essentially this follows IUPAC, but there are obviously a few bits that are NMR specific that IUPAC does not specify. So when you've got stereo-specific assignments, then again we just follow IUPAC. However, if you've got non-stereo-specific assignment, then we're going to use X and Y to differentiate between the two atoms. And if you have degenerate chemical shifts, then we use this % sign to signify that. And I hope it goes without saying that if you have a CX atom, those will be bonded to HX atoms, and CY atoms are bonded to HY atoms. So where does that leave us in total? Well, it means that NEF has a format which is easily read and also edited by humans. That's always quite convenient and certainly better than XML files, for instance. It is fairly lightweight, so the sections that have been made mandatory are fairly limited. It is also flexible and easily extendable. So as I say, programs can easily add their own save frames, but also within a single save frame they can easily add parameters that they want to provide. So if a program starts generating a particular value that it thinks would be useful for other programs to know about, it can just add that in, and then any other program who wants to harvest that can do so, but if they don't know about it, again, they won't fall over, they just ignore it. And then the next 2 points perhaps are the most important. So traceability of data. So this means, for instance, in your peak lists, each peak is given a unique ID. So peak 1327, when it leaves my program, goes into the NEF and goes into another program, remains peak 1327 when it comes out of that program again. And each time you're reading in and out, that peak will always stay peak 1327. So that means as you're going through different rounds of structure calculations, if you're using different programs to do structure calculations, you're then going on to do your validation, that peak will always remain peak 1327, and you can trace that throughout. The other important element about NEF is that finally it is a way of completely and accurately documenting non-stereospecific assignments. So this really has been a big problem so far, that this information is not accurately deposited in any of the databases. So particularly if I have a structure that I've calculated in ARIA, ARIA will swap my non-stereospecific assignments to try out which one is the correct one, and that information about which chemical shift is associated with which atom is known to ARIA, but that information is not relayed anywhere else to any structure validation programs, to any databases for deposition. That information, once it's been lost, is gone and can't be recouped. Now finally NEF allows us to correctly store that information. A NEF file in association with a corresponding MMSIF file will tell you which chemical shift relates to which atom, even when you've got non-stereospecific assignments, and when that assignment varies from model to model within your ensemble. Most of the documentation around NEF so far has been geared towards developers. We've now got a little bit of information here on our website for users. So how do we then envisage NEF allowing us to use information in conjunction with other programs? So the idea is that you can essentially always convert your data into NEF, read it into another program, then go back to a NEF file and then back into another program. We've now implemented most of that in version 3. So for a long time now already you've been able to export NEF files, and you can specify which parts of your project you want to export. We've now, new in version 3.02, also got a new NEF importer. So rather than just importing a NEF file as a whole project, which is what was happening so far, you can now choose which elements from an NEF file you want to import. And if there are any clashes between names, between what you're importing and what already exists in your current project, then you can simply rename things. Long term, we're probably heading to something a little bit different, where you would have a structure calculation plugin which would allow you to specify a lot of things around your structure calculation within analysis, and then that whole conversion to NEF, the running of the structure calculation and getting the data back via NEF again would actually be rather more under the hood and hidden, and would happen without you being as explicitly aware of it as would be the case initially. So let's have a look at NEF compatibility. So Explore can now read and write NEF files. In fact, I think Charles did a special new release in time for the conference. Cyana is able to write NEF files, but is still at the moment not reading them. But I think Elisa is working with Tepe. He's already got various scripts to do that, and we're certainly hoping that by the time the next Cyana release comes up, that will be done. ARIA has just recently finished all the code for reading and writing NEF files, and we're testing that at the moment, and then the new release is due in the autumn. Yazara can read but not write NEF files at the moment. Unio, Amber and PSVS are not at all compatible at the moment, but we know that they are to some extent working on that. So hopefully, particularly as they see that some of the other programs are already compatible, they will be working with us soon to test this and get all of that up and running. And then finally, the databases, the BMRB and the PDB, are both accepting NEF files, and if something has been deposited as a NEF, then you can also write it, or as it were download it as a NEF file as well. Now that's all very well for these programs, but of course there are some programs which are not NEF compatible and which are never likely to become so. Perhaps most prominent among those is Talos, and of course that's very widely used. Our plan for Talos is that we will write our own plugin which will do the conversion of CCPN data directly into Talos format and allow you to run the program and then directly import the results back into analysis. So to sum up the way in which we see analysis version 3 interacting with other programs, we've got NEF, which will allow us to interact with structure calculation and structure validation programs and also the deposition databases. We've got plugins as a means to connect to those programs that are not NEF compatible, and in the future perhaps also as a means to connect to your program. And then there are macros, which will allow users to do some of their own customization and perhaps their own bespoke data analysis on a slightly smaller scale. So I really hope that what I've been able to do today is to perhaps inspire some of you to give macro writing a go, see that this is possible. I hope I've managed to convince those of you who are writing your own programs that the version 3 environment is a good environment in which to do that, and that going down the route of a version 3 plugin is a good way to go. And for those of you who have been missing the format converter in version 3, I hope I've managed to show you that waiting for NEF to come online properly is going to be worth it, because what we're going to end up with is something that is superior to anything the NMR community has had to date. So it just remains for me to say thank you to everyone who's been part of this work, in particular my CCPN colleagues, also Gary and Brian, who have contributed a lot to the project. Thank you also to all the previous CCPN crowd upon whose shoulders we stand. And then thank you obviously to everyone who's been part of the NEF effort. Thank you for the developers for implementing the code, and thank you to the validation task force in particular, who over the last 6 to 8 months I think have had pretty much fortnightly intercontinental Zoom meetings. So thank you for all the time and energy that you've invested in this.